Good afternoon, everyone. My name is Mehran Anvari. I'm professor of surgery at McMaster University. I'm delighted to be invited to share my 20-plus year experience in remote surgical education, something that really I've been engaged for a big portion of my research life. Really, the advent of minimally invasive surgery in the late 80s and early 90s really put a big pressure on provision of education to remote surgeons living in distant parts of various countries, including Canada. In Canada, 1/3 of our population lives in remote regions, and for the last 60 years, most patients requiring very advanced surgeries required to be transferred to our tertiary centers in the south. However, with the advent of minimally invasive surgery, the general surgeons in the north who did provide sort of a broad range of general operations such as hernia repair, cholecystectomies, even bowel resections, and sometimes even fundoplication, etc., found themselves with inadequate training to be able to offer the same range of surgeries, and they were seeing increasing number of patients having to be transferred south. At the same time, it was really not that practical for them to take time off to come and receive a mini fellowship to get more training to be able to offer these more advanced minimally invasive procedures. So the notion of somehow translating knowledge and education using technology became a more popular idea, with telementoring in the 1990s becoming a very common place in Canada. Certainly, there were some discussions today in your program about the advantages of telementoring, and this is one of the early experiences with me training a surgeon in remote parts of Quebec, and he's trying to do a paraesophageal hernia, which is an operation that he could do before open, but now wanted to learn to do laparoscopically. And we found that telementoring, especially if you have access to Telestrator, and I know there was some discussion about the common language, is a very effective tool. However, what we did find is that if the surgeon did not have some of the more advanced skill set required to be able to even complete the task that required, that the telementoring was inadequate. This led us a few years later when Jack Maresco in 2001 demonstrated the feasibility of tele-robotic surgery, even though the surgery itself was quite just a one-time research to show that it's feasible to operate a robot from a distance, led us to think that maybe there's a potential to augment telementoring experience with the use of robotics so that the remote expert can actually take over part of the surgery or perform parts of the surgery as necessary as part of the training. So a couple of years after Jacques Maresco, we initiated our rural telesurgical program, where by ability to send some robotic arms to these community, I was able to either support them during surgery or initially do the surgery itself completely and show them how the various things. This is actually me performing a Nissen fundoplication, and I'm in Hamilton, Ontario, and the patient is in North Bay in northern Ontario, some 400 kilometers away. And as you can see, this is the first surgery. I did almost the whole surgery completely, and the remote surgeon was assisting me. And slowly, as we did more cases, I was able to allow the remote surgeon to do more and more of the operation, to the point that after around 21 surgeries, he was able to do laparoscopic Nissens, laparoscopic spleens, laparoscopic colon resection. And that was really a very eye-opening experience to show that with marriage of robotics and telecommunication, we really can extend the reach of surgical education. This slide again shows the two surgeons collaborating. Here, the local surgeon, Dr. McKinley, is actually doing their surgery, and two instruments are his, and the two instruments retracting are actually mine remotely, and I'm actually assisting him with the use of robotics and telecommunication. I'm 400 kilometers away, and I'm actually directing him here. I'm holding the right crura up so he can dissect up. And you see me in a second pointing out where the posterior vagus nerve is and how he has to protect it. And again, this is an important aspect of surgical education, the ability to actually interact real time, show them. And again, in this case, the latency is 175 milliseconds, and it was really almost real time. And here I am actually holding up, and I'm telling him which plane he has to dissect behind to get the left crus up and without damaging the posterior vagus nerve. So really, as some almost 18 years ago, we were able to show how tele-robotic surgery was potentially a game changer in this field of surgical education. Sadly, unfortunately, the company which was very much involved with this, which was Computer Motion, was taken over by Intuitive. And at that time, telesurgery and tele-education was not a big part of their economic and commercial pathway. And so they shut the programs down. I was fortunate at the time that NASA and the Canadian Space Agency and the US military took an interest in what we did with telesurgery. And so I was asked a question, can we deliver surgical care in an extreme environment in absence of the surgeon? Of course, you can see the potential interest for them because of the potential long-range space missions and where astronauts can be sent where there may not be a surgeon. Can we actually provide telesurgery? With respect to Earth, I was interested because our own experience with satellite as a mode of communication showed me that it was impossible to get latencies low enough to be able to do telesurgery. And the question was, can we actually do this in a different way? So for various reasons, we got together and we were able to conduct a number of interesting experiments with potential focus towards long space travels and where people can be away a year and a half from the Earth and latencies of between 20 and 40 minutes. And as I said, these are environments which, although there is no gravity, they're really not very conducive to normal, and people can get injured, there can be accidents, there can also be a variety of medical conditions that may need some emergency surgical interventions, such as pneumothorax, such as kidney stones, such as potential perforations and drainages required. So the question, we initiated 3 NEMO missions. This stands for NASA Extreme Environment Mission Operations, which is off Key Largo in a habitat called Aquarius, which is underwater. And US and Canadian astronauts and international astronauts are often sent there to get some training done prior to going back up to the space station. So it's a great training ground because it is an extreme environment. It is quite small. It's very comparable to the space and the space station. In fact, it's even potentially smaller. And because they're underwater, they are really cannot just come up quickly because of the bend. So it is also potentially dangerous for everyone. As I said, we did 3 missions. The first mission, NEMO 7, was focused on telementoring and understanding how we could potentially teach astronauts to do procedures. And we found that to be effective, but similar to telementoring with surgeons, we found that certain procedures that required fine levels of dexterity, it was not possible. So in NEMO 9, we looked at shipping a transportable robot which could be assembled on the spot in the habitat to be able to do remote telesurgery. And in fact, I was able to do a variety of remote surgeries using this, as I said, quite a crude robot here, but a system was also set up in the Aquarius which allowed this. One of the things we did try was to tie a suture at 2 seconds, which is the time latency between here and the moon base. And I found this to be almost impossible because human brain can adapt to latencies of up to 300 milliseconds quite easily. but a 2-second latency to try and suture, it took me almost 10 minutes. And at times you make you feel quite sick because you have to actually predict how the two hands are doing. And so for NEMO 12, we focus on automation. So if we have high latency and we cannot do remote telesurgery, can we automate part of the procedure and remotely get the robot to complete the task, send images back, and then be ordered to complete the next set of tasks and be planned. So planning and automation. And this was quite simple. We were able to do venopuncture in an automated manner in a cadaver, but it was just basically to show that we were able to increase the capability of automation. And as such, we started to invest in a variety of development of systems, mainly for terrestrial programs for early detection and treatment of breast cancers, early detection and treatment of prostate cancer, various neurosurgical, where we actually can use automated systems to actually pre-plan and perform the procedure. So automation became an important aspect of tele-application because it will allow people to reach areas remotely where latencies are high. And some of our northern communities, such as in Nunavut, which was using microwave, that latency was not only high, but also unreliable. The problem arose that with automation, you still have to fractionate the procedure and to be able to get signals back and decide what the next plan and action will be. But as I mentioned, on a mission to Mars, we're dealing with up to 40 minutes of latency. And that made even automation of various procedures difficult because if you require that level of automation, you might as well work towards autonomy. And so that became the focus of our work over the last 5 years to say, can we achieve telesurgery in absence of a surgeon using an autonomous robot, which can be pre-programmed for a variety of scenarios which can diagnose and treat without the need to have a physician supervising it immediately. We're really happy that over the last 5 or 6 years, we've seen a significant advancements in the field of cognitive computing and AI. And certainly in my neck of the woods, around Toronto, Canada, has been a big focus of various industries investing heavily in AI technologies, including IBM and Google. And when you look back at the evolution of surgical robots, this is something that's been published for years, that most of the systems we are currently using are master-slave devices, such as Da Vinci, where the surgeon operates a console, which in turn operates the master, but it's fully controlled by the surgeon. As I showed you, there are now increasing number of automated systems which are very task-specific and can be pre-programmed to perform various tasks, probably at the higher capacity capability than humans can do. And of course, the next level is autonomy, where it requires some degree of machine learning and adaptive learning to be processed. And as I said, this is the field which is really, we've seen significant advance over the last decade. And what we are now seeing is AI application in medicine is evolving. Of course, Google AI and IBM are the big powerhouses, but there are a whole host of other companies which are entering the AI field in medicine, and you are seeing up to significant publications every year in the advancement of usage of AI technology in medicine. In the last 3 years alone, over 200 papers have been published, and you've seen papers to suggest that AI is probably more accurate than radiologists in reading mammography and other CT scans, etc. And it's not surprising, therefore, that you can see applications which can use these level of capabilities increase. We are now looking at a number of cancer diagnosis, which we have seen an increasing level of AI technology come to the market where we can actually make those diagnoses using AI much more accurately. And so we were questioning, is there a possibility to combine that type of AI technology with robotics to actually enhance the treatment so that the system can screen the patient with whether it's mammography, MRI, CT, make a diagnosis, biopsy, and potentially treat at the same time. This really would change the current paradigm of screening, diagnosis, and treatment for various solid cancers that we encounter. 3 years ago, we received a grant from the Canadian Space Agency towards that to be able to combine one of the automated systems we had built for inbore MRI, breast biopsy for patients who have very small lesions identified in the breast. Our system is capable of automated tracking of the lesion and biopsying it inside the bore of the MRI. The question was, can we combine an IBM Watson MR screening tool, which can actually diagnose and then communicate with the robot about the presence and coordinates of the lesion to be able to get the robot to biopsy and ablate using cryotherapy. So we were able to show a proof of principle 2 years ago that indeed this is possible. And we were able to, again, using phantom breath to show that the system was able to screen, diagnose, biopsy, and treat the lesion without a need for any human intervention. And this has led us to make applications to the federal government to allow us to get us the funding necessary to build 2 autonomous systems, one for early detection treatment of breast cancer and one for early detection treatment of prostate lesions using prostate brachytherapy, which can be done in an autonomous fashion at the time of the initial screening. I won't go much to do that, but just to say that in my view, autonomous robots, which combine cognitive computing with robotic capability, are going to be an exciting next frontier in the field of robotics. Of course, initially they're going to be simple needlescopic procedures, but I think they will advance to more complex robotic procedures. I know, for example, there are companies which are working at completely autonomous or semi-autonomous robotic joint replacements such as knee. So you will see an increasing number of such systems come to the market. Of course, there are regulatory barriers which will be immense to overcome such a level of autonomy in a system which is performing simple or complex surgical procedures. But I think the health economic impact is going to be significant. It will certainly liberalize access to many of such surgeries across various countries, across various regions, without the need to have the best expert available to you. So where I do see the future of telesurgery, I still am a strong believer that telesurgery and telecollaboration using standardized master-slave devices for latencies of less than 300 milliseconds is still very effective. So I'm hoping beyond Intuitive, other companies which are providing or building master-slave devices will provide that level of telecollaboration capability within this. I think the 5G technology is going to make this even more applicable because we are able to connect between sites without a need for landlines even, and with latencies definitely less than 300 milliseconds. I do believe automation and tele-planning for latencies of more than 300 milliseconds is necessary. And autonomy is something which is the next frontier and will be able to support all latencies irrespective of distances. And I think it's a very exciting frontier for all of us to follow closely. How does this impact surgical education? I think we've already seen that the current pandemic has increased investment in technologies which enable distant education and delivery of care. I know a number of speakers today have spoken to this. Telementoring, telesurgical assisting, and telecollaboration, I'm hoping will find an increasing use in a common place in surgical education, especially with the wider application of 5G, which is a very exciting technology when it comes to be able to give remote access from one site to another. And I believe this will liberalize the access to expert and expertise, irrespective of distance from each other. So I really feel we are facing an economic recession at the moment, and innovation in these fields will play a role in helping us get economic growth and recovery. And one of the things I've learned in working with astronauts over the last 15 years is that you really cannot be content with the way things are. And as they all say, we need to shoot for the stars. I wish you all the best success in your future endeavors in this field. And again, thank you for the opportunity to be with you today. Thank you.